Better late than never. Chapter 1.6, definition of the derivative. Super important section. It's also a really easy section. All they're wanting you to do is just set up the limit. You don't even have to find it. Right? So our function here is named g, and it is the function 3/4 x squared plus 1/2 x. Then g prime of x is defined to be the limit as h goes to 0 of g of x plus h minus g of x all over h. So what I will do then is looking back at my original definition of g of x. What I'm going to do is instead of it saying 3/4 x squared plus 1/2 x, I'm going to transform this in my mind so that it says 3/4 of this thing squared plus 1/2 times this thing. And this is what I really want to use. And my limit then is the limit as h goes to 0. And I'm just going to write two instances of this, one of them minus the very same thing. 3/4 of this thing squared plus 1/2 of those things. And then minus, and then the very same thing. And the only difference between these two guys will be what goes in the parentheses. Otherwise, they're identical. So if you put the same thing in the parentheses, if I put the same thing everywhere, then the numerator would just be 0. And since h is going to 0, we have a 0 over 0 indeterminate form. The thing that I put in the first set of parentheses is x plus h. And in the second set of parentheses is just x. H is down here. And still, since h is going to 0, we would wind up with that indeterminate form. But now, to get it looking like an answer that the computer has put, I should, I guess, well, actually no. This is fine. So the brackets that I have are extraneous. They were there just to help you see how it was the difference of, it was a difference of two things, and that those things were identical. I don't really need them here, except for right here I have to tend to that minus symbol, but the computer responses have g of x still collected together in these parentheses, so it looks like we are all good. Then our answer here would be the last one. Which of the following is a valid formula for the instantaneous rate of change of this here function? Well, instantaneous rate of change is our interpretation of what the derivative gives us. Because the slope of the secant line is the average rate of change, so then if I'm finding the slope of a tangent line, it must be the like average rate of change, but over what interval? There's no more interval since it's just tangent, so it's kind of like the instantaneous rate of change where your interval has dropped down to be a single point. The derivative of f is going to be the limit as h goes to 0 of f of x plus h minus f of x all over h. By definition. And it will always benefit you to write down this definition first. It will help you not make any mistakes. Limit as h goes to 0. And then here's where I'm just going to kind of view my function. Instead of having x's, it's just got empty parentheses, right? This helped another student that I was working with, so I thought I'd share it with all of you. So right there in the first set of parentheses is my function, and then over here in this second set of parentheses will be the same thing. Only difference being that in the first one I'm going to put x plus h's, and in the second one I'm just going to put x. And then it's all over h. Alrighty. Well, we're done. The computer has this as one of the answer choices. The only difference is that they don't have these brackets here. You absolutely still need them over here because that minus symbol would have to distribute into those parentheses. So our answer is this guy. Here's the function e to the 2x. We are going to make friends, really good friends, with functions like this very shortly. And they want to know what is the definition of g prime of a. Well, look, it doesn't matter what I'm putting in here. The only thing that matters is that the symbols match. That's what matters, is that the symbols match. And they have, all they've done is ask me for g prime of a. So I'll need to take a limit as h goes to 0 of g of a plus h. What if they just said g prime of 2? Well, then you'd be putting 2 here, you know. But they want to talk about a. That's okay with us, so here we are. And our function is e to the 2x, so this would be the limit. Don't forget your limit either. That's important, because without the limit, it's not the derivative. The limit of e to the 2, and then there's my parentheses, minus e to the 2, and then here's my parentheses, over h. And then the thing that goes in the first set of parentheses is this, the a plus h. And in the second set of parentheses is the a. All right. well, that does it. That's our answer. Do not say that it's this one. It is not that one. That one doesn't have the parentheses around the a plus h. It's this one. All right, this should be the last one. It's the square root function. So f of x is a square root function, and they want to know, by definition, what is f prime of 4. Well, that would have to be the limit as h goes to 0, and your job is to make the symbols match. So it's whatever this symbol was plus a little bit minus whatever that symbol was over that little bit. And we're letting that little bit shrink down to nothing. Well, okay. So using my function then, this would be the limit as h goes to 0 of the square root of this minus the square root of that over h. Here's a 4 plus h, and here's just a 4. Go ahead and simplify the square root of 4 to be 2, right? You'd have the limit as h goes to 0 of square root 4 plus h minus square root of 2 over h. And that should be the end of the homework. Let me point out to you, though, that in each problem of this homework, I was forced to use the plus h style of, I was forced to use the definition where h goes to 0. It's not really the one I prefer. It is every bit of it is precisely equivalent for us to say something like f prime is exactly equal to the limit as, let's say, w goes to x of f of w minus f of x over w minus x. And on quite a few problems, this version is easier to deal with because there's no composition of functions. There's no x plus h that I'm needing to substitute in. Right? If you wanted to keep filling this thing out, then you just have that f prime of x was equal to the square root of, the limit. It would be equal to the limit as w goes to x of square root of w minus square root of x over w minus x. And, if you wanted to take this all the way home and solve it, well, then you'd need to somehow get it so that it's not in an indeterminate form. Because right now it's in the form, right now it has indeterminate form 0 over 0. Well, let me just take advantage of the difference of two squares property and multiply by 1 in the form of the conjugate of the numerator over itself. Because then that numerator would just become w minus x. And my denominator would be w minus x times square root of w plus square root of x. Well, then these will cancel. I'd have the limit as w goes to x of 1 over square root of w plus square root of x. We're no longer in the indeterminate form. W is going to approach x, so this would wind up being 1 over the square root of x plus the square root of x. You get 1 over 2 root x. All right, we'll talk more later. Bye.